So hello, everybody. Welcome to our number 4 think tank, Innovation in Regulation and Airspace Integration. Urban air mobility is definitely a new type of aviation. It evokes a new type of aircraft. It means a new way of transportation for our cities. And many even call it a new Wright brothers time. It's definitely a very exciting moment. And as we move forward in the idea of implementing this new type of aviation in our cities, that brings a whole set of challenges. And one of the most important challenges that we need to resolve as an industry is how these air vehicles are going to be integrated into the airspace in the city, how we're going to orchestrate the traffic of air vehicles, how we're going to make it safe, and how are we going to actually share that airspace with traditional aircraft like airplanes and helicopters, and how we're going to integrate and share the airspace with a new type of aviation, which are drones, the unmanned systems that will definitely come into service in the near future in our cities as well. It's very important for us as industry to work together with the regulating entities, the aviation authorities, to innovate in everything having to do with the new types of regulations that are required, and also to create the new airspace integration architectures to make all this happen. Hi, everybody. My name is Felipe Varon. I am the founder and CEO of Varon Vehicles. And I want to introduce a very, very interesting panel that we have today, very dedicated to airspace integration and regulations. We have today joining us Edgar Rivera, the Director of Regulations of Aerocivil, Colombia's Civil Aviation Authority. He's a lawyer specializing in aeronautics, space, transportation, and procedural law, has represented Colombia in ICAO, university professor, and has published articles on aviation and law, private pilot, and reserve major of the Colombian Air Force. Joining us is Mauricio Gomez from the Procedures Office of the Colombian Civil Aviation Authority, Aerocivil. He's in charge of the country's UTM program, a retired colonel of the Colombian Air Force, flight officer and crew member with over 25 years experience in operations, logistics, and aeronautics administration. He's led development of policies and standards and has been chief operating officer of a drone services company, drone pilot and instructor, and school faculty member. Ahmed Ganjo, founder and CEO of ANRA Technologies, an award-winning drone operations and UTM platform provider used by commercial and government entities. Ahmed has over 20 years of aviation, telecom, and wireless experience in both the federal and commercial space. He's an engineer, licensed pilot, builds and flies experimental aircraft, and is a board member of the Global UTM Association and a member of FAA's Drone Advisory Committee Working Group for UTM. Joining us as well is Rex Alexander, an aviation entrepreneur and industry leader with more than 40 years of military, general, and commercial aviation experience. He's owner and president of 5 Alpha LLC, a global aeronautical consultancy specialized in infrastructure development for the helicopter and vertical lift industries, and is the infrastructure advisor to the Vertical Flight Society. With us as well is Peter Shannon, founder of Radius Capital and an early stage investor in advanced aerial mobility. His firm tracks over 500 startups relevant to enabling advanced aerial mobility, and he's also active in the public sector side, advising NASA, and is a co-author of a national strategy for advanced aerial mobility in the United States. And finally, but of course not least, is Justin Towles. He's a senior policy advisor in the advanced aviation practice at Aiken Gump, where advanced air mobility is a key focus area. He has spent the past several years working closely with NASA, with the FAA, and industry to enable a robust passenger transport system utilizing eVTOL aircraft. Joining us as well today is Andres Bejarano, our Director for Investor Relations in Varon Vehicles.
Hi,
so welcome everybody. Please note that we are recording this session and it will be posted in the Skyscraper website, webpage, varonvehicles.com/skyscraper. So you can revisit this and any other previous think tank at any time. Attendees, you're able to submit your questions through the questions and answers button on the bottom of your screen. And at the end, we will have an 8-minute slot in which we'll try to answer as many questions as possible between all panelists. Please note that the language of this think tank is English, but we have live interpretation in both English and Spanish. So you just have to go to the interpretation button on the bottom of your screen and choose your preferred language to listen to live interpretation of this session in your language of choice. Por favor, note que el idioma de este think tank es inglés, pero tenemos interpretación en vivo tanto en inglés como en español. Usted solo tiene que ir al botón de interpretación en la parte baja de la pantalla y escoger su idioma preferido para escuchar interpretación en vivo de esta sesión en su idioma de preferencia. So great, guys. Let's get started here. Now, why don't we do it different this way? Why don't we go backwards and start with the last person I introduced for a change and get started with our first point. And Justin, to you, when we talk about urban air mobility, we really have to produce a shift in mindset from the aeronautical perspective in aviation, which means, of course, many probably century-old and well-established paradigms, and we'll come to those a bit later, but we have to shift from the aviation point of view into an urban perspective. Urban air mobility intends to solve city problems, like the mobility problem, like city growth problem and the lack of mobility infrastructure. Urban air mobility, as we see it in Varon vehicles, is a new type of infrastructure. It's virtual, not physical infrastructure. With that shift in perspective, how do you see the two really cope when you have aviation and when we talk about efficiency and airfoils and air traffic control and all those elements of traditional aviation? And we come now and try to establish those in an urban scenario where people are thinking about mobility. When we talk about the different modes of transportation, when we talk about an airspace over a city, and it's a low altitude airspace over a city that we intend to occupy. And that really calls for a change in perspective. So let's get started with that and go from there, Justin, and then to the rest of the guys from there upwards. Justin?
Yeah, thank you, Felipe. And again, appreciate the opportunity to be on this panel. This is one of the really interesting areas kind of in my mind, because for the past number of years, I've been in the aviation sector, but I also come from state government, local government, kind of a political world as well, where there's a lot of focus on, kind of city integration, the public kind of perception and acceptance of this. And more than ever before in the aviation industry, we have to consider both sides of that. So you're right. I think, from one sense, we have to be careful that we're not just building aircraft, specifically from the aircraft engineering perspective, but also from the customer and demand perspective of both passengers that are going to be actually flying in these and the cities that are going to be integrating them. And, this is a delicate balance of trying to bring all of those things together to create a kind of a unified market and to try to land all of these things at the same time, where we're hitting the technological barriers at the same time, the airspace integration barriers, the physical infrastructure, vertiports or vertihubs, whatever we're going to eventually call them, and all of those standards. And while, meeting public acceptance and the regulatory kind of hurdles that we're going to hit, not only at the federal level and at the country level, but also subdivisions, or in this case in the United States, with states and city governments. That's going to be a huge challenge. And I think you're right. We need to start cracking paradigms. And, one of the ways to do that is really to start socializing this broader with communities. If we're just talking among technologists, vehicle manufacturers, and airspace professionals, within kind of our insular industry, this won't end up working. We really need to engage at a high level and make it a priority of industry to engage at a high level with local governments, with city governments, state governments, and the public to figure out exactly how all this is going to integrate seamlessly at the end. So I'm sure lots of others on the panel have things to say about it. I could talk obviously all day, but I'll turn it over to others.
Absolutely. So working backwards for a change, like I said, why don't we go to Peter, over to Peter. What's your point of view on that?
So my point of view is, as we go and exploit this application for urban air mobility, we have to be really conscious of some of the scaling factors in the vehicle manufacturing capacity, as well as the ability to bring the levels of technology and to support the density of flight that this urban air mobility application really demands in order for it to be truly cost effective and to serve the level of movement demand from people in that given region. And so I think that it is really prudent for us as a community to take those considerations into account right alongside social acceptance considerations and be rather purposeful with crafting the types of missions that we want to introduce so that we set ourselves up to be successful, so that we're successful from a regulatory compatibility standpoint, so that we're successful from the economics of the early operations, and so that we are compatible with the scaling ramp that is going to be required for the aerospace industry to produce these vehicles at the volume and at the cost points that this application demands. And so I think that it is an incremental, it's going to be a stepwise introduction of the technology. There will be human piloted operations dominating in the early years. And there will be a lot of work going on in the airspace system outside of the vehicles in order to lay the groundwork for the communications and for the data exchange and for really the system-wide architecture that we are going to put in place in order to enable the higher levels of density.
Absolutely, and that's a really, really crucial aspect of our activities. It's realizing that we need to achieve public acceptance, community acceptance, because that's where the customer base is going to come from in the first place. And that's the space that we're going to be occupying. That airspace is not where traditional aviation happens. It's actually over communities, over cities, and basically more within cities, right? Because these eVTOL aircraft are going to be actually occupying those spaces. So with that, let's pass it over to Rex. What's your point of view there? And I think, why don't we talk about one of those very, very important points in the cities, which is the mobility problem, and how we recognize that in many parts of the developing world, like Latin America, where we are focused in, the mobility problem is really more intense. We not only have the traffic layer, but we have other layers that make the mobility problem much worse and impacting people's quality of life in a much, much worse way. So, Rex?
No, you're exactly right. I think we here in the U.S. and other countries take for granted the access we have to transportation, and other countries don't have that same access. So, venturing into the third dimension in the air is a great way to reduce that ground congestion. Also, it's a great way to enhance safety and security for those areas that are a challenge. Aviation transportation has generally represented much longer distance transportation models that we're contemplating here. Urban mobility is going to be a much shorter, more and conducted in a different dimension. So altitudes are going to be much lower, flight legs are going to be much shorter. This is going to require a paradigm shift in our thought process, and integration, as has been said already, is going to be huge. I think for that population, local policy, urban planning is going to be a major key to success in moving forward in this, and community acceptance is everything. So, that will be a key to anyone being successful in this industry, and education will be a big proponent, and not only education, but proactive education.
All right, great. So, Amit, you and your company develop what is basically required to be the virtual infrastructure. The UTM technologies and those softwares are the way in which urban air mobility is going to basically occupy this space. Is how the traffic is going to be, the traffic is going to be orchestrated, is how the virtual lanes are going to be defined, whether they're corridors or not. So your perspective on this is really, really interesting, because it's your systems and that type of technologies that are going to allow these things to happen. So tell us.
First of all, Felipe, great. It's great to have such great panel and hearing everyone's insights. So I appreciate the opportunity to kind of share our thoughts. What you mentioned is right. So the way I think about it is, and I think a lot of other folks, it's what we are in is in a marathon. It's not necessarily a sprint. So there's a reason why the safety standards in the aviation world are higher than any other form of transportation. Because when you're, if you're on the driving in your car down the road and something goes wrong, you pull over to the side of the road. But if you're in the sky flying in your aircraft or UAM vehicle or anything else like that, you can't just pull over to the side of the road. It becomes an elevator at that point. So the safety standards from the aviation, from the aircraft point of view are there, but then the surrounding infrastructure, because what we have to look at is more in terms of a crawl, walk, run methodology. And what can you do in crawl phase? There are technical challenges, but it's not just there. I think that there are pieces of technology that exist that help us meet what the objectives are, but you have to look at it at a more broader perspective, more than just the technology aspects, the social acceptance aspect, the policy, the regulatory overlay that is required based on the demographic and the country and the geography. Because what may, like was rightly mentioned by Rex, what might work in the Americas, in North America or in Europe may not work in Latin America. Or in Asia or in Africa for that matter. So you have to make those subtle changes, but you still need to factor in certain key aspects. There were some comments made about like, this is low altitude airspace. I agree, it's for UAM, yeah, you'll have a lot of traffic in low altitude airspace, but there will be transitions that will happen which require a mixed use airspace. And even if it's not big manned aircraft, you may have low flying aircraft that has to traverse the same airspace. So how do you do this integration? And how do you ensure the safety of the national airspace system? How do you minimize the air risk and also consider the ground risk at the same time? Because doing an operation in, for example, I'll use US as an example, downtown New York has a higher, in Manhattan is a higher risk than me doing it in the middle of cornfields in Iowa. And even if you set up these, you can set up these dedicated corridors, and Peter alluded to it, like initially, a lot of these UAM flights are going to happen under VFR rules. That means they'll be piloted, like, so there'll be a pilot on board and you can fly along with other traffic. Now, there are options, there are discussions like Felipe, you outlined in your documentation as well, having maybe a dedicated corridor just carved out for that traffic. That works in an experimentation, innovation phase, but I always talk about going from innovation to innovation experimentation to operationalization phase. So innovation experimentation like that is it's a crawl step, but as you move towards walk and run, as you move towards operationalization, you have to look at the integration. So even if you're in low altitude and something happens and I need to create a dynamic constraint and ingest it, what does that do to my traffic? What does that do to that airspace? And also, what does that do to my vertiport operations? It's not just these virtual high lanes in the sky. It's also the vertiport infrastructure that is doing approaches and departures. So that's the kind of high level thought. So there are a lot of these variable pieces. All of them need to be looked at together. And for us as a company, that's what we do, because yeah, the airspace management is one aspect of it, but there are a lot of these other pieces. UTM is just the glue that holds a lot of these other pieces together. It's an enabler. It's not the end all be all.
Absolutely. Mauricio, you manage the UTM systems for Colombia and the Colombian Civil Aviation Authority. So please, what are your thoughts on this?
Thank you. Bueno, Yo quiero
Okay,
tocar
I want to
primero un tema que
talk
hablaba
first about something
Rex
that Rex brought up,
y Peter sobre la
and
educación.
also Peter about
Más que
education.
educación, aquí en Colombia nos
More
ha
than
tocado iniciar un
education, here in
proceso
Colombia we have
de
had to start a
evangelización,
process of
que es enseñarle
evangelization, which is
a todas
to
las personas
teach all
que
of the
nunca han estado
people
en el mundo
that have
aeronáutico
never been in the
a
aeronautical
saber
world
qué es el mundo
to start
aeronáutico y
knowing
qué es
what the
usar el
aeronautical
espacio aéreo
world is and what is
con
to use the
aeronaves como los
airspace
drones,
with aircrafts
lo
such
que
as
nosotros
drones,
llamamos de
what we
400
call
pies
400
hacia abajo.
feet
Y también
down.
tenemos
And we
un
also
cliente que nosotros llamamos
have
aquí
a
en Colombia
customer that we
interno,
call here
y es
in Colombia
al
the
interior de
internal
la aeronáutica
customer, which
civil
is that
y
within
al interior
the Civil
de las
Aviation
entidades del
Authority
gobierno,
and within the government entities,
irles enseñando, irlos
we need to start
capacitando
teaching
en
them
todo
and
lo que
training
tiene que
them
ver a
regarding
futuro con el uso
the
de las
use
aeronaves no
of
tripuladas y todo
the
lo que tiene que ver
unmanned
con movilidad urbana
aircrafts
y
and
también
urban
con
mobility
los diferentes
affairs,
usos
and
que tienen
also
los
with the
drones.
different applications of
Estos
for the
son
drones.
dos
These
temas grandes que
are
estamos
two
trabajando
main
en Colombia,
topics that we're
es
working
la
on in
capacitación, como les
Colombia,
digo
which
yo,
is
aquí yo lo
the
llamo a veces
training, as I
evangelización,
said, as I
es
call it,
al
which is
cliente
to
interno
teach
como al cliente
the
externo
internal and
cómo va a ser
external
todo ese
customers
proceso
how the process is going
de
to be
poder utilizar el
regarding
espacio
being
aéreo de
able to use
400
the
pies hacia abajo
airspace from
con
400
las
feet
aeronaves
down
a futuro para
with the
el
aircrafts
transporte de personas
in the
y los
future
demás usos de
for
los drones.
transport of people and the other applications for drones.
Absolutely. So, Dr. Edgar Rivera, we are talking about, because you have just joined in, the shift in perspective that urban air mobility may require us to have from aeronautics per se, in the traditional aeronautics, into an urban perspective, and how does that change impact what we are doing to actually have these systems come to fruition, urban air mobility systems, and that in terms of airspace integration and in terms of the new regulation. And at the same time, how we recognize that there are city problems, very endemic mobility problems in Latin America that we need to tackle, a customer base in cities that we need to approach and obtain a public acceptance from. So why don't you give us your thoughts on that before we move into our next point?
Gracias, Felipe. Muy buenos días a todos. Y
Thank you very much, Felipe, and good morning to
ofrezco
everybody.
disculpas por no
I'd
haberme
like to
unido a
first
esta reunión
apologize for
unos
not being
minutos
able
antes como
to
debería,
join
pero
this
lastimosamente se
meeting
me
a few
alargó
minutes before, as
más de
I
lo
should
previsto la
have.
reunión en la que me encontraba desde las
Unfortunately,
9 de
the
la mañana.
previous meeting
Bien, en cuanto
went longer
a
than I
este cambio
thought.
y a esta condición y a
Now,
esta
in terms
adaptación
of this change and
del uso
this
de estos
condition
vehículos
and,
a
and
la
this
movilidad
adaptation of using these
urbana,
vehicles
para la movilidad
for
urbana,
urban mobility, for urban
es
mobility,
necesario tener en
it
cuenta
is
que sí,
necessary to bear in
se trata
mind
primero que todo a partir de que se trata de aeronaves
that
y que se
first of
trata de
all, it is about
adaptar toda
aircrafts
esta
and
cultura,
is
toda esta
about
reglamentación
adapting this culture of this regulation,
aeronáutica a la movilidad urbana de vehículos que estarían volando
aeronautical
a muy baja
regulation,
altura, que se
to the
puedan
mobility
integrar
of vehicles that would be
que se puedan
flying at
integrar
low height, for them to be able to be integrated
al sistema de transporte urbano. Ahora
to
bien, al menos en el
the
caso de
urban
Colombia,
transport system.
tenemos ciudades
And
como en el
now,
caso de
in
Bogotá,
the
donde
Colombia case at
efectivamente
least, we have cities such as Bogota,
el
where
transporte
of course
urbano,
the
el transporte masivo,
urban transport in the
no es
mass
precisamente
transport
el más
is
eficiente,
not
y
precisely as
lastimosamente
efficient as it should be, and where
infraestructura vial no creció al mismo
unfortunately
ritmo que creció la
the
ciudad,
road infrastructure hasn't grown at the same pace that the city
pues que
has.
esto
And so
comporta una
this
necesidad. Ahora, entonces la idea sería
brings a need, and then, well, the
articular
idea
los
would
requerimientos en
be to
materia de
put
regulación
together
para
the requirements in terms of
el transporte
regulation
urbano, articularlos con los requerimientos
so
en materia de
that the
regulación
urban
para
transport
el
can be
transporte,
integrated
para
with the
el transporte aéreo
regulation
o para
elements
la
for
movilidad
the air
aérea en general.
transport or
Entonces,
for air
básicamente, digamos,
mobility
esta sería
overall.
una primera
So
aproximación.
basically, this would be the first approach, so to speak.
All right. Thank you for that. So let's talk about those paradigms. We were mentioning that there's a need to break paradigms, probably century-old paradigms in aviation, as we move into occupying the city airspace and implementing urban air mobility services. So what can we relate to that, and what can we what can we say about it? The simplistic approaches. Amit was referring to that. Of course, we have to crawl, then walk, and then eventually run. What does that mean in terms of actual airspace integration? Are we looking? There's different options. Corridors, very well established corridors, predefined and predetermined, are one approach. We are certainly in favor of that. Of course, like Amit as well said, the challenge is scaling from there. It's scalability, it's growing. Of course, a different approach is to design for more complexity. So what do we see in terms of the value of a simplistic approach in breaking those paradigms? Guys, anybody want to jump in?
Sure, I'll offer some thoughts. I think that it is enormously valuable for this industry to get into the air and build some experience in these new types of operations. With that, we are going to have, we're going to learn a lot, obviously. We're going to accumulate a lot of data. That is going to be important for informing the design refinements of these vehicles. It's going to be important for understanding the early business models that actually work. And it's going to be incredibly important for regulators to build confidence around the safety case in these operations, et cetera. So the crawl phase is so valuable to us. And I think that we need to think constructively right now about the ways that we can make the most out of that phase. What can we do within the existing rules to build as much experience as we can? What can we do to enable as many of these applications that we aspire to as we can within the, essentially think of these rules that we have today. They're tools, they're at our disposal. They are ways that we can operate. And if we take that path and we think, all right, with VFR, with other existing rules around operations and vehicles and infrastructure, what can we do to generate the most data, to build the most experience, and to learn so as to purposefully inform ourselves in the right direction? And so I mean, that's an interesting question actually for Rex, because he has so much experience in exactly this type of a space to think about, well, what are the possibilities within VFR operations in an urban environment? What can we leverage? What can we do? What type of density can we achieve? What type of operations can we support? And on the back of that, what are the key pieces of data that we pull out of it? I do think that as we look ahead to higher levels of density and more sophisticated, more automated operations, today we have in the airspace system, we have visual flight rules, we have instrument flight rules. Instrument flight rules are very structured. They don't require that the pilot be able to see and avoid other aircraft around them. But the instrument rules and the airspace architecture built for those, it's designed for higher performance aircraft that are generally on longer journeys. So using instrument flight rules for urban air mobility really requires a rethink. They are not a drop-in solution for what we want to do. And we're probably going to build an adaptation, based on some of the same math, the same theory, the same safety constructs, in order to build flight rules that go beyond VFR, that do support automation, but for short journeys between more numerous sets of destinations in a region, so more densely spaced landing spots, and that support higher density. But that is that's at the research stage right now. That's a work in progress. If we do this the right way, we are going to operate in the near term under visual flight rules in such a way as we generate critical data to inform that new structure. We don't want to have to go and invent things from a totally clean sheet of paper. We always want to stand on the shoulders of the progress and the data and the safety cases that we have and leverage those into future adaptations that serve our needs. So this is, you know, if there's anything in the systems engineering question around what we are doing here, it really lies around these combined priorities and how we chart a path through them that achieves all of them.
Right. Well, we value simplicity a lot. Actually, the fact that we can work on the idea in Varon vehicles of having permanently reserved airspace volumes linking vertiports where no other aircraft, no other drone is allowed to go in, and only within that, only urban air mobility air vehicles are servicing with a specific architectural. That's a very simplistic approach. Anybody want to jump into that?
This is Amit, and that's one approach, Felipe. I agree, and I guess it depends on the regulator and where you're talking, because some regulators may be amenable to creating that dedicated corridor, where others may not, and it depends on which part. Are you doing it in the downtown area or someplace where there's a very busy airport, or are you doing it in the middle of nowhere where there's nothing? So what we are seeing, and this is real, without getting into specific, what we are seeing based on our engagements at a global level is it's a wide variety. In a lot of places, they would it's going to be, we know for certain the initial flights are going to be manned, like it's going to be piloted before it becomes purely unmanned at scale. But what we are seeing is because of I'll go back again to the risk, right? And Peter pointed out, like, till we can do all paper studies all day long, but till you actually get into the air and capture some metrics, things break when you go out into the field. Things don't break when you're doing in simulation or on paper. So what we see happening a lot more is in low risk areas where even if you have a dedicated corridor, but if it's above a dense urban area, so you may not bump into other aircraft, but you may actually have a failure and cause some damage or fatalities on the ground too. So what we are seeing is a lot of people look at this UAM concept paradigm, but look at it more for moving cargo initially versus humans in there, because then your risk factor went down significantly because it's cargo versus people in their stuff. And then they're looking at opening and closing these corridors, not having a persistent corridor, like for a particular, because it will open up for a window and then you close. That's where you do the slot, like kind of time slotting in the legacy ATC days is like basically the same concept, but it's in 4 dimensions. You're managing the volumes in 4 dimensions in space and time and opening and closing. And that's what we feel. You have to look at it from a risk point of view. If you go out there and then you have to do the dedicated corridor one, but you may have to look at find the middle ground and experiment somewhere. And it'll vary from region to region.
Absolutely. Mauricio raised his hand, so please, Mauricio.
Okay. Bueno, algo importante.
So something that is important here that we've done in Colombia is what we're doing with Felipe Varon in his project. And it is that every step that he wants to take with the vehicles, he shows it to the Civil Aviation Authority, and we're working together, and we tell him whether it's possible or not to do so with the infrastructure that we currently have. So the industry and the authorities shall work the step by step together, so that the person that wants to develop it is not going to invent something that won't be able to be applied in the country, or that has some sort of issue to be solved. The other thing is that the step-by-step that is developed by the industry, within the Civil Aviation Authority, we show it to the different entities that are part of the Aeronautical Authority, so that they are also aware of how the industry is moving along and what does the industry want to do, so that the regulatory entity can get prepared in the future for us to implement together, both with the industry and the authority, a great system, and most likely, and that is very safe. That's what we all want, that at the end is a safe system, and that we can control it administratively and operation-wise. That is very important.
Excellent. Who else wants to jump into that point? That point.
No, I would agree with everything that's been said so far. The way we conduct air traffic control today, via voice and radio, that's not going to work for this transportation model. most air traffic control facilities don't have the facilities and the bandwidth and the staff to deal with additional workload. As a helicopter pilot flying in, very heavy, dense traffic areas and in and around urban environments, I've often been asked to stay out of the way and please be quiet, we're busy. Automation of air traffic is going to be a huge piece in handling a lot of the throughput that we're looking for. I do see, I think, as Peter said, I don't see us doing IFR operations, but I do see us doing VFR, visual flight rules, operations at a high fidelity IFR constraint to achieve the accuracy for the traffic separation, which will then give us the flow that we're looking for. But the simplistic approach to separating traffic, provide dedicated and protected routing structure, probably not achievable in the United States. It's not the way our system is designed, but in other systems, in other countries, I think it's definitely, if you can do that and separate the airspace, that would be a great way to get going quicker. It would definitely allow for faster. And at the same time, it would provide you the information moving forward to do the research, the study, and provide the data to then achieve that next step.
Great. Yeah, I think Edgar raised his hand. Please, Edgar.
Gracias. Sí,
yes, thank you very much. Thinking about the specific regulation regarding in what we call in conventional aviation air traffic rules, these are the rules that would regulate the circulation. I believe that we should handle that under the following consideration: to avoid and, of course, segregating once again a part of the airspace. We're talking 400 feet down, first of all, to accomplish safety. But it's interesting because in drone aviation that we can compare with, we have already started to think about the possibility that they can start sharing the airspace with conventional aircrafts and to fly in non-segregated spaces. As a matter of fact, I've seen recently in the social media channels information that accounts for a first landing of a unmanned aircraft in Israel in a commercial airport, interacting with other aircrafts and being able to land. This is great progress, but here, though, I don't see it as easy or as likely. First of all, because we are not interested that these aircrafts fly high, but especially because if these aircrafts are interacting within the same airspace that other aircrafts, they're taking on an unnecessary risk. When we have tried to avoid that the drones share the airspace with conventional aircrafts, we do so thinking that a drone that crashes against a plane can have a big impact. We don't really think about the drone much. If it's destroyed, doesn't really worry us much. If it falls on the ground, we don't think it's going to cause significant damage. Eventually might injure a person, but we don't really concern much about it. We are actually thinking about what might actually happen to the conventional aircrafts in terms of the fact that a drone can cause severe damage to that aircraft. But the situation turns around here. Here we must be concerned about this situation where there's people on board, and we must think that the sole proximity of a vehicle that is doing urban mobility, the proximity to a conventional aircraft, could actually generate an accident to this vehicle due to the turbulence wake that it leaves behind. And that right away makes us think about the need of that this apparatus have a segregated airspace for the safety not of the conventional airplane but these devices. Knowing this and knowing that we need them to fly at a low altitude and knowing at altitudes that are so low that most likely are not perhaps attractive for conventional aircraft, that should not represent any difficulties. So knowing now that they have a segregated airspace, that they have their bubble where they can fly in Now we should have the peace of mind that they can fly without interfering one with the other. So perhaps not the level or under the mindset of instrument rule sets, and not under the concept of this type of separation that is established for conventional traffic, but in any ways, though, some provisions that guarantee that they're going to be separated from each other, whether it is time of takeoff and commute, or I don't know if it's perhaps through devices that the technology will have to develop, probably similar to the TICAS systems, right? Because for the alert systems in the aircraft, so to avoid crashes, not only against the ground, but against other vehicles or aircrafts. But the regulation shouldn't be complex, I believe. If we can get to define some corridors, if we can define what are the specific airways for them, they use themselves only, that are not even used by the unmanned drones, but solely for them, I believe this would make the regulation not very strict or stringent or complicated. Now, with that being said, where do we need to go with our regulation? And I insist, if we can separate from the conventional aircrafts and we can establish these corridors, I don't believe that we require a very complex regulation. Where I do see complexity in the regulation is in the requirements of the apparatus, the navigability devices, and the rules of navigability. We need to have some requirements that are stringent, because there's some people going on board, and we need to have rules that guarantee the integrity of the people. And our effort, main effort, perhaps should be aimed towards this aspect. Thank you very much.
Yeah, I think we've touched very, very relevant points, and this may all come together in the fact that trying to see what Peter and Amit and actually everybody and Edgar just mentioned, we need to think about a graduality in urban air mobility. We cannot really talk about air taxi just now. That's probably one of the last applications of urban air mobility. We are well going to be transporting packages before we transport people. And that's what Amit said. We first have to walk before we run. But there's actually even prior activities before providing any services to logistics companies like freight transportation. There are a number of activities that we can do to demonstrate these technologies, to test them out, to gather data, and not involve any services or any passengers at all. And actually, that's what we call our crawl phase. And if we start with segregated corridors, very pre-established, predefined, well, that could be a great way to get started. Not that it's going to be like that once we reach the other stages further down the line. So again, the question is how to scale up from there. Anybody else wants to jump in to any of these points?
Yeah, sure. Thanks, Felipe. I just wanted to point out a couple of things to think about. I think we've had a good, robust discussion on this, but one of the things that constantly comes to mind that's important for us is to have a unified vision as not only an industry, but also bringing in other stakeholders, like what we talked about before, the public, cities, and governments, the federal government. And we have to have a unified vision of the ConOps on this. So that's starting to happen. I think NASA in the US has put a lot of effort into developing that and did a lot of outreach. We've been a part of that, and I know others on this call have. FAA is now doing that as well. And as soon as we can kind of have a better understanding of our end, well, not only our end state, but the progress toward that, we can all start working together in a seamless fashion. Because one of the things we have to remember is the market. You know, my previous company was part of one of the market studies for NASA, but there's several of them out there now. And the reality is, especially when we start looking at corridors, like you said, corridors are a good idea, I think, potentially for the crawl stage. But when we start talking about looking at the market where this actually works, we're talking to high hundreds, if not thousands of operations in any given city in any given day. In order for that to work, you start looking at placing corridors from each of those vertiports, which is estimated to be between 50 and 200 vertiports for a city in order for this to work effectively. you start looking, that airspace looks like a bowl of spaghetti. And in the United States, at least, that adds additional complication because there's political factors at play. You know, you can't have all these dedicated corridors because that then makes VFR flight for general aviation impossible. And that's not going to fly politically here. And it also complicates, you know, other commercial aviation. So there's a lot of considerations that we have to think about and you know, in that respect. And basically we get to a situation where we're trying to work on evolutions of two things. Things that Amit, for example, understands very well is UTM, that low altitude operation. There's low altitude operations happening with generally smaller UAS below 400 or 500 feet. These operations are going to be much higher than that, likely. So we're going to have to increase what we've been doing with UTM while pushing what's happened with ATM, you know, with next gen ATC and so forth. And we're going to have evolutions of both of them kind of meet in the middle for something new. Words have been floated out there, UAMTM, UTM inspired ATM, you know, whatever that is. It's going to be some marriage of the two. And, you know, the more we can work together to define what that may and is likely to look like through the various stages, I think that's better because, you know, we can design the airspace architecture and everything that we need kind of in a unified fashion moving forward.
If I can add to what
Please.
Justin just said, Justin, if you don't mind. So he brought up a very valid point. So like, I think there are initiatives like the NASA AM, which most of the folks on this call are probably familiar with. We are an airspace provider there. So there's a lot of work that is done in that, and it's using the same crawl, walk, run methodology. And similar stuff is happening in Europe, like for initiatives like H2220 UAM or like Future of Flight initiative in Europe. And that's very region specific, geographic specific. So you can tailor it to your use cases and what needs to happen. And something similar would probably work very well in Colombia, which tailors it and creates this in the crawl phase, this experimentation kind of environment. And another thing Justin touched on is, and maybe it is possible in the Colombian airspace, but what we are seeing elsewhere, it's not going to be below 400 feet all the time at all. It's going to go above, it's going to be mixed use airspace. So you have to account for that. So even for NASA AM, they're using, and I co-chair the ASTM standards, which is working on UTM, and we are moving from UTM to UAM to upper E as well. So higher altitude unmanned stuff as well. So the UTM standards that were put are being used as a baseline for those of you who are involved in AM, the X3, the first iteration of the NASA AM campaign. And then we are adding additional requirements for going beyond the low altitude airspace to add the additional use cases and ConOps and what's needed to modify those to account for that. If that concept is used down in Colombia, I think that would be ideal to set up that experimentation phase and tailor it, because what's working for NASA or for Future of Flight or for H2020 may not necessarily work for Colombia, but a variant of that. So something like that is definitely worth investigation.
Cool. Anybody have a thought on that, or shall we add to this the point about safety? I mean, we all have referred in one way or the other that safety is first. Nobody, absolutely nobody, can cut any corners in safety procedures, and that brings to the table the subject of certification. It's a big question still out there. Who's going to certify these air vehicles? Actually, like Justin was saying, it's very true, those numbers. One of the questions is, are we going to see such big numbers in the developing world as we implement urban air mobility here? Even though we reach a run phase where we are servicing air taxi and so on, public passenger applications, are we going to see so many numbers in developing world cities? Do we need 200 vertiports in cities like Bogota or Panama City or Chile, Santiago? It's just a big question, because the developing world is quite different than the developed world, and the requirements for EM in turn are different. So let's go back to the question about, and if anybody wants to add any thoughts, let's try to juice it up here or spice it up with a certification question. Who's going to need to certify this aircraft? Is it going to need to be the local authorities? Is it going to need to come certified by the FAA? Are we going to need to see some middle ground where the local authorities are going to take a role and play a role in certification processes? I think I got to raise his hand.
Gracias. Bien, antes de hablar
Okay, very
de
well. Before
certificación,
talking
lo
about
primero que hay que
certification, first
definir
thing we
es
need
una
to
norma,
define is
un
a
estándar de
standard,
diseño, una
a
norma
rule for the
de
design for
aeronavegabilidad
air
que
navigation
indique
that
qué
can
características, qué
state what are
requerimientos
the
debe tener un
features and
aparato.
requirements
Por vía de ejemplo,
a device
hablando de
must
aeronaves
have.
convencionales, aún
Speaking
tratándose de las
about
aeronaves más
conventional
pequeñas, de las que
aircrafts,
llamamos de
even the
categoría
smaller
normal,
ones, the ones we call normal category,
los estándares de
the
aeronavegabilidad
air navigation
hacen alusión
standards
a
speak
aspectos como
about
estructura,
aspects such as the
requerimientos para
structure,
estructura
the
que sea lo
requirements for the
suficientemente
structure that is
robusta
robust
para que no
enough
se deforme en
so that
vuelo,
it
para que en
cannot
caso de
deform
impacto
during the flight.
proteja a los
In case of a
ocupantes,
crash, it
etc.
can protect
Requerimientos
the
en cuanto a sus
passengers, the
características del
requirements in
vuelo,
terms of the
que el
flight
aparato sea capaz
features
de
that
volar
the
con seguridad, que sea
device is
capaz de
capable of
mantenerse en
flying
vuelo,
safely,
unas
that can
velocidades
keep being
mínimas de
airborne
sustentación,
in a
etc.
sustainability speed
En cuanto a
in
equipo
terms
mínimo de a
of the
bordo que
minimal
debe
onboard
tener
devices that it must have
la
uh,
aeronave. En
within
el
the
caso de aeronaves, desde
aircraft
luego que no
in
sería este el caso de
case of the aircrafts, which would not be
se
the
propulsan
case
seguramente con motores que tienen
with
combustión,
those that have
sistemas
combustion
de
engines,
prevención
which
de
is
incendios. En este
fire
caso, pues quizá un
systems.
motor eléctrico de golpe también
Electric
podría
engines could
provocarlo
perhaps also cause a
a menor
fire, but
escala, pero
to a
podría.
lesser degree, but it
Este tipo
could.
de
This
consideraciones hay que
type of
tenerlas todas
considerations need
orientadas
to be all
a la seguridad,
connected
de tal
to the
suerte que
safety
quien
so that
diseñe una
whomever
aeronave
designs an
debe
aircraft
asegurarse que cumpla
must
con todos
make
estos
sure
requisitos. Y
that they
ahora,
fulfill
si
the
viene la certificación, se
requirements,
certifica el
and if
diseño
there's a
en
certification, you certify the
consideración a que
design
el
based
aparato
upon the fact
cumplió
that
con
the
toda esa serie de
apparatus
requisitos.
met all of the different
Certificado el
requirements.
diseño, tenemos la certeza
As
que
far as the
cualquier aeronave
certificate, we
que
have
se
that
desarrolle a
any
partir de ese diseño
aircraft that is
certificado
developed
ya
for
será
a
navegable.
certificate will be
Estoy
air
explicándolo
navigation
cómo funciona la
safe.
aviación convencional
And
y
I'm
miramos a ver cómo
talking
lo
about how it
trasladamos
works
a
in the
este tipo de
conventional
aviación.
sector and how can we convey this
Cuando
to this
el
type of
diseño cuenta
aviation.
con un
When
certificado
we
tipo,
have a
posteriormente cada
certification,
aeronave individualmente
eventually
considerada
every aircraft
deberá obtener un
considered must
certificado de
get
aeronavegabilidad
a
en el
air
estado donde esté
navigation
matriculada.
a
Que
certificate in the
casi
state where
siempre es el
they're
mismo estado donde
registered, which
opera,
is
no
the state where they
necesariamente.
operate, but not necessarily.
Entonces tenemos dos
So we have two
certificaciones. Una
certifications, a
certificación de tipo al
certification
diseño y a
of the
todo lo que se
type of the
produzca a partir de ese
design and
diseño.
everything that came
De hecho, se
after
habla
the
también de un certificado de
design. They
producción
also speak
y un
about
certificado
a
de
certification
aeronavegabilidad
for production and
individualmente
for air
considerado a cada
navigation,
aeronave.
individually
Si
considered for
trasladamos
each
eso ahora sí a estos
aircraft. And we
vehículos,
bring this to these
podría
now
ocurrir lo que ocurre hoy en la práctica
vehicles
con las
in
aeronaves
what happens
convencionales.
today with the
Ellas vienen con su
conventional
certificado
aircrafts.
de
They
tipo.
come with
Al menos en
their
Colombia.
certificate, at
Colombia
least in Colombia.
no es
Colombia
un país
is
que esté
not
pidiendo
a country
certificados
that is
tipo. Colombia ha
issuing
pedido dos
certifications.
certificados
Colombia
tipo
has
únicamente. De hecho, hay muchos países que no han
type
pedido ninguno.
certifications that have been issued by
Pero
Colombia
sí
only
han
twice,
pedido miles de
but
certificados de
thousands
aeronavegabilidad.
of
Lo
certificates
que
for
ocurre es que aquí llegan
air
aeronaves con su
navigation. We have
certificado tipo
aircrafts coming in
otorgado por
with
la autoridad
certificates that have been
aeronáutica
granted
del
by
estado
the
donde
Civil
fue
Aviation
diseñada y
Authority
construida
where
y acá
it
se les
was
otorga su
designed
certificado
and
de
built, and
aeronavegabilidad.
here
El
we
esquema
provide the certification
no
for air
creo que
navigation.
sea muy
The
diferente.
methodology,
Las
I don't
aeronaves
think is going
deberían
to be
venir con un
different. The
certificado
aircraft
algo
shall come with a
parecido al
certificate somewhat
certificado tipo,
similar to the type
y la
certificate,
autoridad donde ha de operar
and the
bajo su
authority where it's
responsabilidad
going to
debería
operate under
constatar
its responsibility
que
needs
cada
to
aeronave
check that
individualmente
every
considerada cumple con los
individual aircraft
requisitos
meets
bajo
the
los cuales
requirements under which
su diseño
the
tuvo el certificado
design
tipo y si lo
had
cumple,
a
otorgarle
type
un certificado de
certification,
aeronavegabilidad
and
o algo
if it
parecido. Se
meets
esperaría que
it,
fuera,
can
a
be
pesar de
granted the
todo,
air
un poco
navigation
más sencillo
certificate.
en
In
cuanto
spite
que
of
las
everything,
normas
I
de
think it
diseño
could be a little
debería
bit more
también ser más
simpler
sencilla,
because the
el
design
proceso de
standard should be
certificación
simpler, the
debería ser
certification
más
process
sencillo.
should be
Pero
simpler
indudablemente
as well. But
una
without a
autoridad,
doubt, an authority,
seguramente la
most
de Colombia
likely
o cualquier
the
otra,
Colombian
no iría a
authority or any
permitir el
other,
vuelo de
would
una
not
aeronave que
allow
no
the
esté
flight of
certificada,
an
ya
aircraft that
usándolo
is not
comercialmente,
certified
experimentalmente
using
seguramente sí,
commercially.
pero ya
As far
usándola
as the experiment
comercialmente
goes, maybe, yeah,
como
sure.
un
But
servicio
commercially,
económico,
as a service, it
ninguna
needs to
autoridad iría
have
a
a
permitir que una
certificate,
aeronave
and no
esté
authority should
transportando
allow
personas
people
como servicio
to
público si no
be
está
transported
certificada.
if the
Luego, esto
aircraft is not
será
certified. So
necesario.
this will be
En la
necessary.
medida en que
As
los aparatos sean
the
tripulados por un piloto que lo
devices
conduzca,
are manned
seguramente
with
habrá
a
unas condiciones y
pilot,
unos requisitos mínimos para
will
ese
need to
piloto,
meet
que
some
seguramente
minimum
esto será
requirements
mucho
for this
menos
pilot,
complejo
and it will be much less
que
complex, of
pilotar un
course,
avión,
that flying a plane.
pero habrá unos
But there
requisitos
will be
mínimos
some
también
minimum
para este
requirements as
piloto.
well
Claro que
for
esta
this
sería
pilot,
materia
even though
para otra
this
discusión
would
igual de
be a topic for another interesting debate. But in terms of the certification, yes, they need to be certified. They need to have some air navigation conditions. They need to have type certificates in the country that they were built, and the state where they operate needs to grant a certificate similar to air navigation certificate that we currently have.
Right, Peter, I think you wanted to jump in.
I was just going to agree with those statements about the importance of certification and the fact that the certification is going to come both, perhaps with the aircraft, but also from the local jurisdiction in which it's going to be flying. That's the way that it has worked, and that's certainly, I think, continues to be applicable in this model as we go forward. This is an example of building off of constructs that we've already made use of, that we have experience with, and that we know that work and produce results.
Rex?
No, I agree with everything that's been said. I think in looking at this, aircraft certification as it pertains to performance and how that relates to supporting infrastructure will be a key point of success to anything we do in the future. Any adopted standard will need to address several of the unanswered questions that we have for these aircraft. And I think those can be done in that crawl phase that you refer to. When we're looking at that, we're looking at, okay, how will these aircraft be affected by urban environments with heat islands, wind flow, architecturally induced turbulence, especially high altitude? How will they perform in that environment? How will these aircraft contend with known aerodynamic issues that we contend with in the helicopter world? Will they be affected by settling with power, vortex ring state, and weathercock stability? And there's several others. How will they handle the stresses of landing at near max gross weight more often? Since we're not burning fuel, we're landing and taking off at the exact same weight.
Yep.
Will they be capable of achieving the equivalent or greater level of stability that a helicopter would in the same environment? Or will we find that some of the wing-borne systems are susceptible to handling issues? I've seen some of the profiles out there for some of the vehicles, and some of the transitions from forward flight to hover are rather aggressive. Will we have the room to achieve that? Will it be safe? So I think in that space, we look at what is capable, what is safe, and again, go back to that crawl phase. I think we can achieve a great deal in testing and figuring that out.
Yeah, that's actually our last point of conversation. We have a very limited time here, but it is the question about what value do we see as an urban air mobility community, global stakeholder community, in a place where we can implement faster at a lower cost and actually do everything required all the way into placing into service faster and simpler. What value does that have, and what value does Latin America bring to the table of global urban air mobility stakeholders, air vehicle manufacturers, subsystems providers, airspace integration systems like UTM, vertiport designers, passenger management systems, ground energy, self-production systems, for example, all those subsystems, all those stakeholders that are involved in urban air mobility. What value could we see in Latin America as a region where we could start implementing urban air mobility faster at a lower cost and way, way simpler? So I throw that question out to you, to whoever wants to jump in.
Well, I'll just say this, and I'll let some of the others that are probably better experts in Latin America chime in on how specifically they could accelerate. But one of the key elements, this plays into the last question and to this one as well, I think, is where certification meets manufacturing. I mean, that is going to be a key element for this particular industry. And what we're seeing is really interesting, and I thought this would likely be the case, but we're seeing a marriage of experts in manufacturing, high production manufacturing, high output, like vehicles, and then and where that meets with the aircraft manufacturers. And we're starting to see that with involvement from companies like Hyundai, companies like Toyota, now recent announcements from GM and others. Their expertise in starting to produce these more high-tech ground vehicles. Some of them include electric vehicles, highly automated, automation, things of that nature, and then kind of your typical aviation type manufacturing, which is often high tech but low volume. And where do they meet in the middle? And there's going to have to be some adjustment in the structure of type certification. Right now, for example, in the U.S. and in the EAS as well, they're moving forward with type certification of some of these aircraft. They just announced recently that we'll probably have something within 2 years. But as that progresses, and you have 200 plus companies that are in current, design or development of a vehicle, it's going to really be a major kind of sea change and paradigm shift at the EASA, the FAA, other certification bodies, they're going to have a different way of handling this, and they're going to probably need some structural changes in regulations and law to be able to handle those as we move forward. Right now we're in the crawl phase, and then eventually walk, and we can get up and running with testing and demonstrations and kind of low volume. But as we progress, there's probably going to need to be a little bit of an adjustment there to accommodate this particular type of aircraft.
All right. Anybody else on that?
I think, Felipe, I was just going to add is to address your specific question, what can Latin America do and make it attractive and lucrative for different players in the ecosystem to flock there? I think it all boils down to the business case and the regulatory acceptance and the framework available. If you have a business opportunity there and a business case, and the regulators are on board in making that business case a reality, that's what's going to drive, because that's what will take it beyond the experimentation and going beyond. So if that happens to be Colombia, I think you'll have people flocking. So
great. Anybody have any other closing statements there?
Sí, respondiendo un poco a la pregunta que ofrece.
Yes, thank you. Answering to the question about what Latin America offers, in the first place, there's a need, of course, for most of the Latin American capitals. Air transport, urban air transport is a need. If we see that cities such as Sao Paulo, Brasilia, or Mexico City have urban air transport through helicopters, I believe also Santiago de Chile maybe. In Colombia, this was not possible in helicopters because there are some environmental considerations, environmental authorities, and the community actually did not accept these type of aircrafts because the helicopters are noisy and they were going to cause pain to the people or bother the people. This was actually set up and designed, basically implemented. The urban transport through helicopters had to be canceled for these environmental considerations. These type of vehicles that would not be noisy, that contaminate less, would have overcome this difficulty, because basically there is a need, of course, an important need here because of what I said. I mean, the surface traffic, ground traffic is extremely dense, and there are some uncomfortable and difficult conditions in the sense that urban public transport is not the best quality. And it is not only the case of Colombia, most Latin America, so this would be a solution for this need. There is a need, first of all. In second place, the availability of the authorities, at least the Colombian authority. The CAA of Colombia has been on the lookout, very interested in this sort of projects, this sort of mobility. The regulatory capability, we have it. There's the capability so that when the time comes in order to start generating the regulations, we have the capability with the advantage that the authorities are working closely, or we have a responsibility in terms of the regulation. We have been working closely with this matter so that it's not going to be difficult to address the regulatory affairs. It's usually important to know the technical fact, then bring it to regulation. And sometimes it's hard to know it at first, but here we've been working very closely for Colombia to have the possibility to regulate this industry. Is not too far away. Nonetheless, Colombia, when the technology of unmanned aircrafts or drones, Colombia was one of the first countries that started to regulate this matter. And with the peace of mind, the regulations that eventually came about from other countries were not very different to what Colombia had already done at the beginning and that had done from before. Let's hope that the same happens here so that we have that regulatory capability that would facilitate to establish a market that is brought by the need, but especially as the question is more not about the Colombian realm, but the Latin American realm, let's just say that the situation is not really different for the other countries. The main capitals of Latin America, or the first capitals of Latin America, have a very similar reality in terms of that the need is the same, the regulatory capabilities similar, and with an advantage in the LATAM realm around the regulation, and it is that most of the Latin American states work their regulations together jointly, while it is true that ICAO shoots for greater standardization in the regulations of the states. For the CAA authorities at the LATAM level, this standardization is greater because all of the states actually work together jointly on drafting these regulations, and there's a lot of information sharing. So whatever is done in a country, it'd be easy to replicate in the others. If some country does it first, the others can replicate easily. If this country is Colombia, we hope it is Colombia, there is a great possibility that the other states can replicate it and vice versa. So all of these are certain conditions, special conditions, in order to be able to achieve or to show Latin America as an attractive spot for this type of transport.
Fantastic. I appreciate that very much, because we indeed need and are working together as industry with the regulators, especially in our case in Colombia, to develop those airspace integration architectures and regulations to get started with urban air mobility faster and at a lower cost and in a much simpler way. We do have a bit of an extended time here. Unfortunately, we need to close now. This is, airspace integration and the regulations for airspace are one of the biggest barriers in urban air mobility, definitely. So it's a very deep subject. Does anybody want to make a closing statement before we finish this think tank? All right. So with that, I want to really thank you all for participating. It is indeed a very interesting topic and definitely a very deep one, like I say. And certainly by working together with us as industry, together with global urban air mobility stakeholders, with local regulators, where we are setting to implement our first systems and our first operations, it really opens a lot of doors to break that biggest barrier. We think one of the biggest barriers in urban air mobility, which is airspace integration. So thank you all very much for participating. I want to invite you all to join our next think tank. It's next Thursday, September 24th, and it's going to be about cities implementation in Latin America. The question about how are we thinking about actually implementing urban air mobility in actual urban scenarios and the impacts that we're expecting to happen in our cities as we solve city problems. So please join us to that for that next think tank, and thank you all for being part of this very interesting think tank. Have a great rest of your day.
Thank you.
Thank you.